Greetings from the best common sense math doctor in the planet. And the reason I can claim that is I'm the only common sense math doctor consultant on the planet, the name of my company. But I would say that I try to use practical common sense strategies, incorporating the senses to help you and your students remember strategies forever. Do me a favor when we're done and share or tag this math video with one of your teacher friends. Like it on Facebook, subscribe in my YouTube page, and help me get the word out there about practical, applicable, content specific, student friendly strategies that are going to make a huge impact this coming year with your students. And I hope you enjoy it, because I'm about to. Let's get going. This question is from the 5th grade in Texas. If you're in our land, we call it 5.9C, student expectation. It happened to be question number 30 on this past year's test, and only 23% out of the kids in Texas got it correct. So if that many kids in one state are in the state of confusion, then perhaps the entire country or the planet would not do well on this question either. So I want you to notice that it's basically the skill, because we're not all from the same state. It's 1- and 2-step problems using what we're going to call here stem and leaf plot. It happens to be a 2-step problem because your kids had to, on the first step, figure out what the fraction part and whole were. Then, because it wasn't in the answer choices, they had to reduce that to a fraction that was equivalent. So let's take a look at the problem and the question. The stem, tens, and leaf, ones, plot shows the number of laps around a track that several teams, plural, walked as part of a fundraiser for the library. The teams, keywords, highlight, that walked more than 50 laps, not equal to, not less than, greater than 50. That means whatever number that you select has to be higher than 50. Raise an extra $100 for the library. So the question said, what fraction, numerator, denominator, raise the extra money? So the first thing you have to do is say, well, okay, well, they're asking about the ones who raised more than $50. So I'm gonna have to split the 50s down the middle, because 50 is not greater than 50. 50 is equal to 50. So if I count all of these ones in what we're gonna call the leaf side, the ones side, I have 1, 2, 3, 4. That's my fraction part, my teams who raised the money. My fraction whole is the total teams. 5, 6, 7, 8, 9. Let me do that correct. 5, 6, 7, 8, 9, 10, 11, 12. So my first fraction is 4/12 of the team raised the money, 4 out of 12. If you do step 1, I'm going to show you 3 different ways to solve this, and do the division property of equality. 4 divided by 4 equals 1. So basically you're just dividing it by 1, but you're dividing by a common a common multiple of 4 and 12. Well, the number that I can use is 4. So the division property of equality says that if I divide a number on the top and divide the same number on the bottom, numerator and denominator, I will get an equivalent fraction. So 4 divided by 4 equals 1. 12 divided by 4 equals 3. That 1/3 of the teams was able to raise the extra money. And if you do step 2, some of you believe in it, and I do too. When you cross multiply to check, 4 times 3 is 12. 12 times 1 is 12. So you have, when you cross multiply, you get the same number. So it's true that 4/12 is the same as 1/3. Step 3, go to page 11 of my mathematics chart in a section called Equivalent Fractions Common Denominator Guide. So how do I figure out, using denominators that are different, what is it that I could come up with that would work? Well, our answer was 4/12, and I see a 4/12 here in my equivalent fractions guide. So if I work my way backwards, 3/9, that's not there. 2/6, not there. 1/3. What you might have your kids do is finish up my guide, depending on what grade they are in, how far they need to go to, because you can pretty much see that because these are on the same line, these would be equivalent fractions. So how do I extend that for a little bit higher grade? 1, 2, 3, 4, 5, and 6 could be my numerators. 3, 6, 9, 12, 15, and 18 could be my denominators. So if I was to extend that, 5/15 and 6/18 are equivalent fractions to 4/12, 3/9, 2/6, and 1/3. So it's probably important that you have your kids set up an equivalent fractions chart like I did, because it's so easy to do 1, 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12. See how it works? 2, 4, 2, 4, 6, 8. Front numerator, 3, 6, 9, 12. So you just keep multiplying by the same digit on the top, and then do the same thing by the same digit on the bottom. So those are 3 different ways to go from 23% correct in Texas to hopefully like 75%, where you actually look at the questions that are being asked, understand that greater than, let me see, greater than, right there, less than, and equal to are 3 different things. They wanted the ones that were greater than 50. So if I was doing karate math, I would go, huh, greater than, huh, less than, huh, equal to. And that's a little bit of sneak preview on karate math that we'll get into on some other problem. So do me a favor, like always, go ahead and share something you like about one of the strategies in the comment section below. Subscribe in my Facebook by joining my Common Sense Math Club. On sense, as in the 5 senses. Subscribe to my YouTube videos, and stay tuned for our next video, which will be a 6th grade math question that had the most trouble in our state, which would probably have the most trouble in your state as well. Take care, God bless, and have a wonderful school year.